Have you ever looked at something and just thought, man, that finish is invincible? A color that never seems to fade, a surface that just won't scratch? Well, it turns out there's this invisible, high-tech skin covering all sorts of things around us, from our watches to entire skyscrapers. So let's peel back the layers on this amazing hidden world.
Okay, let's start with a really common example. You've got this beautiful gold watch, right? But you know it's made of tough stainless steel. So how in the world do they get that perfect, deep gold color to stick so well that it can handle years of daily abuse without chipping or fading away? I'll give you a hint. It's not paint, and it's not your grandpa's gold plating. The answer is way, way cooler.
The secret is a process called physical vapor deposition, or PVD for short. And what that really means is you're taking a solid material, like say titanium or even real gold, and you're basically turning it into a gas inside a vacuum. Then you let that gas re-solidify, atom by atom, onto an object. The result is this incredibly thin, super dense, and unbelievably tough film that literally becomes part of the surface.
I know, it sounds like something straight out of science fiction, but it's totally real. So let's dive into how you can literally paint a surface using nothing but atoms inside a vacuum chamber. It's a process that's just as elegant as it is powerful.
The whole thing really boils down to just 3 basic steps. First, vaporize. You take a solid block of your coating material and you zap it with a ton of energy to turn it into a cloud of individual atoms. Second, travel. Those atoms fly through a vacuum, an empty space, so they don't crash into any pesky air molecules along the way. And finally, step 3, condense. The atoms land on the object you want to coat and build up, layer by layer, into a perfect, uniform film.
You know, the best way to picture this is to think about a hot shower. You see the steam, which is just water vapor, right? And when it hits the cold surface of a mirror, it instantly turns back into a liquid film of water. PVD is exactly the same idea, just taken to the absolute extreme. We're not talking about water vapor in your bathroom, we're talking about metal atoms in a near-perfect vacuum.
And when I say vacuum, I mean a serious vacuum. The pressure inside that chamber is so low, it's pretty much comparable to being in outer space. And this is absolutely crucial. This extreme emptiness gives those metal atoms a completely clear path to their target. It means no impurities can get in the way, which results in a super pure coating that sticks like you wouldn't believe.
Now that first step, vaporizing the material, there isn't just one way to do it. Engineers have come up with a bunch of clever methods. You can literally heat the material until it boils away. That's called thermal evaporation. Or you can blast it with super-fast ions to knock atoms loose, which is called sputtering. Each technique has its own special purpose, but they all follow that same core idea: vaporize, travel, and condense.
So now that we have a handle on how it works, let's get to the really fun part. Where does this incredible technology actually show up? And trust me, it's in more places than you could possibly imagine, from everyday stuff to some of the most advanced instruments ever built.
Let's circle back to color for a second. That gold watch we keep talking about, it's probably coated with something called titanium nitride. And this is where you can see PVD is basically a form of atomic engineering. By picking different materials to vaporize, like zirconium nitride for a bronze look, or chromium nitride for a cool silver gray, you can create a whole palette of stunning metallic colors that are also insanely durable.
But, and this is a huge but, these coatings are so much more than just pretty colors. The films they create are functionally amazing. They can make a surface incredibly hard. That's part of the reason your phone screen is so scratch-resistant. They provide unbelievable wear resistance, which is why your tools or that watch can look brand new for years. And they stop corrosion and rust dead in their tracks. This isn't just a layer of paint, it's a permanent upgrade to the material itself. And this is where things get really, really important. In the medical field, PVD can be a literal lifesaver. When you coat medical implants, like an artificial hip or a dental screw, it dramatically reduces wear and tear, so they last way longer inside the body. These coatings can also create surfaces that bacteria hate, and they won't corrode, making them so much safer and more reliable. PVD is also right at the cutting edge of energy and optics. You know those super energy-efficient windows that keep your house cool? They have an invisible PVD coating that reflects heat. It's also used to make the hyper-efficient filters on solar cells, helping us get more clean energy, and on the critical sensors in self-driving cars that help them see the world.
Okay, so with all of these mind-blowing benefits, you've got to be asking, why isn't everything coated with PVD? Well, like any super powerful technology, it comes with a few trade-offs.
So on the one hand, it's a really clean, environmentally friendly process that makes these phenomenal coatings. But on the other hand, the machinery you need is complex and very expensive. Creating that perfect vacuum takes a lot of time and energy. Plus, it can be tricky to get a perfectly even coat on really complex 3D shapes, and some materials that are sensitive to heat just can't handle the process.
But don't think for a second that those limitations are stopping progress. This field is moving forward at lightning speed. It's getting smarter, faster, and more efficient every single year. So what does the future of PVD look like?
The next generation is actually already here. We've got new techniques like HiPIMS, which you can think of as PVD on steroids. It creates coatings that are even denser and tougher. Engineers are now using AI to get perfect control over the process, making sure every single coating has the exact color and thickness they want. And the whole process is becoming more energy efficient and smarter as it gets integrated into modern manufacturing.
So the next time you see a flawless metallic finish on a phone, a faucet, or even a medical tool, you'll know the secret. You'll know it's protected by an invisible skin made of atoms, perfectly applied inside a vacuum. And that just leaves us with one final big question. As this amazing technology gets cheaper, faster, and smarter, what's the next everyday thing we're going to completely transform? The possibilities are pretty much endless.